The textbook also goes through the sections that should be included in the TEMP, the test and evaluation master plan. So there's the number 1, the system introduction. Number 2, integration and test program summary. Number 3, development, test and evaluation. Number 4, operational test and evaluation. Number 5, test and evaluation resource summary. Well, let's talk about the system development versus the test and evaluation, but put this in the context of the overall test planning and preparation and what are the steps that you need to be taking. And so we've talked a little bit about the TEMP, the master plan, that's the test and evaluation master plan that needs to be developed. There's also some interesting ways you could be looking at what is done in system development versus what is actually done in test evaluation. And you can see what is actually going on for each one of these. And so you can see that details. And so I'm just trying to give a highlight. I'd refer you back to the textbook to get some more of the specifics. You also, before you do your system test, you want to be reviewing the system requirements. Has anything changed? That needs to be updated to make sure that you're testing to what is currently the on-contract baseline that you have. You want to be reviewing any types of key issues that might be there. Oversight, is management and everyone buying into that? Do you have proper resource planning? And all the test equipment and facilities, are they going to be available for the amount of time that you need? There's a test equipment design. Is everything now fixed and available so that you're going to be able to be doing that? Is it have enough accuracy, enough reliability, and enough flexibility to accomplish what you need to be doing to make this happen? In terms of integrated test planning, there is all kinds of planning that needs to make things happen. Maybe different tests have to be run in a certain type of order. There could be things like that. So before you get into the operational test, you have the development system test. And so you have to be doing the test planning and also the operational evaluation planning. And finally, there's a variety of things that can be issues for common things that need to be avoided. So you can look in the textbook to get some more insight into that. So that's just a quick synopsis and finishing up that section. Okay, we'll just have 2 more quick sections that we'll talk about. First of all, test traceability. The testing should be traceable back to the requirements in order to determine if the requirement is satisfied or not. Most of the modern system engineering tools will have a capability to show a traceability between requirements, functions, components, and tests. This will be valuable when requirements or any other element will change, and to automatically update the rest of the architecture from the affected items. A very effective technique for tracing the requirements to the test are the verification cross-reference matrix, VCRM, where each requirement will have a means of how it may be tested through testing, analysis, demonstration, or inspection. Those would be the 4 things that you would see listed there: testing, analysis, demonstration, or inspection. The first order accounting of test resources can aid initial planning for test facilities, equipment, skill sets needed for future test equipment. So those are some of the details that need to be thought about for test traceability. So the testing should be traceable back to the requirements, and there should be a traceability matrix that you're going to be able to leverage. Okay, well, moving on to the final topic here is system of systems testing. Sometimes your system is not the only thing, but it's going to fit into something even larger. So system of systems are different from single system approach towards test and evaluation. The scale, number of stakeholders, objectives, management, funding, and users are diverse and may have competing objectives. An individual system may evolve asynchronously through the system of system development A major objective of system testing and evaluation should be to help reduce the risk during the system development, integration through the entire system evolution, and collect data from multiple events and sources to inform decision makers of the decision for the system of systems decisions. So you may have an experience where there's be various segments, various large components that are going to be fitting into this larger context, and this is what we're getting the chance to be seeing that. And so each individual system within the system of systems will evolve at different rates. We mentioned that another system of system issues that may arise for the system engineer to consider are who is in charge of the system of system tests, what are all the systems and stakeholders represented in the test, and is the proper data collected and disseminated to all of the participants. So then just to finish up with our summary review, we covered a variety of topics. And so first of all, testing and evaluating the total system. The objectives of the integration and evaluation phase are to integrate the engineered components of a new system into an operating whole and demonstrate that the system meets all the operational requirements. The outputs of the evaluation process are validated production designs and specification, qualification for production and subsequent operational use. The activities consisting the activities evaluations are test planning, defining the test issues, test scenarios, and test equipment, development system tests, verifying that the system meets the specification, operational test and evaluation, validating that the system meets the operational requirements. For the development system testing, developmental system testing has the objective of verifying that the system satisfies all the specifications and obtains evidence concerning its capability to meet operational requirements. The system test environment should be as realistic as possible. All external inputs should be real or simulated. Conditions expected in operational evaluation should be anticipated. Moreover, effects impractical to reproduce should be exercised by special test. However, the entire system lifecycle should be considered. Test events must be carefully planned. Related test objective should be combined to save time and resources. Detailed test scenarios need to be prepared with sufficient flexibility to react to unexpected test results. A predictive system performance model must be developed. This is a major task requirement since engineering leadership and efforts. However, an EDM engineering design model is an excellent for this purpose. Development tests are carried out by a coordinated team consisting of system engineers who define test requirements and evaluation criteria, test engineers who conduct tests and data analysis, design engineers who design test equipment and correct design discrepancies. System performance discrepancies during development testing must be accounted for in test schedules, quickly responding to a remedial plan of action. For operational test and evaluation, system operational test and evaluation has the objective of validating that the system design satisfies its operational requirements and qualify the system for production and subsequent operational use. Typical high priority operational tests include new features designed to eliminate deficiencies in predecessor systems, susceptibilities to severe operational environments, interoperability with interacting external equipment, user systems controls interface. Essential features of effect operational evaluation includes familiarity of customers or customer agents, test personnel with the system, extensive preparation and observation of the developmental testing, test scenarios making effective use of facilities and test results, clear and specific test procedures and detailed analysis plans, thorough training of test operation and analysis personnel, fully instrumented test facilities replicating the operational environment, complete support of test consumables, spare parts, manuals, etc., accurate data acquisition for diagnostic purposes, special attention to human machine interfaces, complete provisions for safety of test personnel and neighboring inhabitants, technical support by system development staff, and timely and accurate test reportings. There's human factor testing. Human factor interactions can include display controls and wearable systems. These activities that represent requirements across the mission lifecycle phases can be asserted for workload, understandability, tolerance to errors. Test equipment tests can evaluate different system configuration, workspace layout, or multi-user operation. For test planning and preparation, integration and evaluation materializes the system as a whole and synthesizes the functional total system from individual components. These activities solve any remaining interface and interaction problems. Defense systems require a formal TEMP, which cover test and evaluation planning throughout system development. System requirements should be reviewed prior to preparing test plans to allow for customer requirements changing during system development. Late injection of technology advances always poses risk. Key issues during system integration and evaluation include intense management scrutiny during system tests, changes in test schedule and funding due to development overrun, readiness of test equipment and facilities. Test equipment design must meet exacting standards and accuracy must be much more precise than components tolerances. Reliability must be high to avoid aborted test. Finally, design must accommodate multiple use and failure diagnosis. For test traceability, the testing should be traceable back to the requirement in order to determine if the requirement is satisfied or not. One technique for tracing the requirement is the test is the VCRM, where each requirement may have a means of how it may be tested through a testing, analysis, demonstration, or inspection. Testing, analysis, demonstration, or inspection. For system of system testing, when testing the system of system issues involving a large-scale number of stakeholders, differing objectives, multiple management and funding arrangements may have competing objectives. Each individual system within the system of system will evolve at a different rate throughout the system of system development. Other system of system issues that may arise for the system engineer to consider are the following: who is in charge of the system of system tests? Are the systems and stakeholders represented in the test? And is the proper data collected and disseminated to all participants? Okay, thank you. That will end it for this lecture.